Hey there, welcome back to another episode of the Magic Box. So in this video, I want to go ahead and do the challenges from the previous video. So as a quick recap, we added the potentiometer after learning how that all works, and we ended up with some code that controls the light intensity of the red light as we turn it. So just a quick demonstration. I'm turning it and it turns on, and then when I turn it all the way on, it gets a little brighter. Okay, so let's go ahead and add in the additional challenges here. So going up to the top here, it says first we want to, we're starting at 3 here. Fade red light using potentiometer with a resolution of 6. So how does that work? Okay, resolution of 3 we have here, meaning that there's 3 different levels. There's 0, 128, and 255. Okay, so but with 6, we want 6 different levels. So we need to add a few more. So we'll go if, let me do some copy and paste here to save time. So start at 0. Let's go 256. Okay. And maybe I'm just going to go in between here. So what is it? Maybe, what is it? Around 60. Okay. So when the potentiometer is at 0, I turn it all the way off to 56, 60, and then let's add another one here. $500. Let's go 750. Then I guess I'll do 180 or something. So now I have 1, 2, 3, 4, 5. Let's add another one. 850, let's say, is 220. Okay. Oh, and then this should not be equal. This should be greater than 256. All right. Okay, let's try this out. Okay, so this gives more resolution, so I have 6 different levels now, right? And then let's turn on my monitor. If you remember our serial monitor, so we can see what's coming out on the analog. Okay, so right now it's 1023. That's all the way on. And if I turn it off, or slowly, yeah, you can see it slowly fading down. Okay. You can see it slowly fading on. And the slower, you can see the different levels if you slowly turn the dial. If you turn it really fast, you won't really be able to tell. Okay, cool. So not too bad. And so on that note, I'm just gonna go ahead and skip number 4 because it's pretty similar. All we're gonna do for 10, for a resolution of 10, that means we need 10 of these in here. Okay. Right now there's 6, so then we would do something like, I'll just kind of show you how to get started. Like here it jumps from 0 to 256, so instead, you would maybe want to do 128 and so forth, and maybe 30 here. Okay, now the numbers I'm choosing, they don't have to be exactly, I'm just trying to kind of evenly create different segments, different levels. All right, if you want it to be super exact, you would want to say, okay, if I have 10 levels and I have if I have 10 levels that I want to do a resolution of 10, and I have 1024 different segments, because it goes from 0 to 123, then you can go 1024 divided by 10. That would tell you how big each segment would be. Okay, which would be, just so that, like, I'll just pull up the calculator so that we know what we're doing here. So you would do 1024 divided by 10, which I believe is 102.4, right? That would say, if you wanted to make it exact, you would make every segment here, 102.4 size. Now you can't do decimals with the variable type that we chose, so I would just say 102. Okay, it doesn't need to be exact. So you would then say, instead of 128, you would say 102, and then the next one would be 204, right? And then the next one, add another 102, would be 306, and so forth. Okay. Now you could do the same thing with the intensity too, if you want it to be, again, just more exact, more evening of the changing of intensity. You would say, well, the intensity goes from 0 to 255, which means it's 256 segments. So if I want to divide 256 divided by 10, 256 divided by 10, which is 25.6, right? Let's just say 26. Then you would use that, and so here 0 0, that's 5. On the second one you'd be 26, and on the third one you add another 26, 52, and so forth. So that's just an example of how to get it to be exact, but really I just want to give you a challenge to get comfortable with changing intensities based on the potentiometer. Okay, so I'll leave it at that. If you have further questions about it, feel free to reach out. Let's go ahead and jump to number 5. Change colors of RGB based on potentiometer. Okay, that shouldn't be too hard. So I'll just leave whatever code. And it's just really saying, let's change the color, not just have it red, but let's go like, I don't know. I'm going to put the green one, the blue one. Sure, red, blue. This is just random here, because the challenge is just like change colors, right? So I'm just turning random lights on at different intensities based on the potentiometer. So let's just see what happens here. Okay, cool. So you can see it's like a white light, then I'm changing it. Oh, it becomes like this bluish thing. Change the potentiometer. All right, so that's just a quick thing just to prove you can change the colors of the lights as well, based on the potentiometer. Now, just a quick recap, why can I just put red, green, blue here? The reason is that these are macros, which are defined up here. Red, blue, green. So red is actually 3, blue is 5, and green is 6. Okay, we went over that in previous video, but in case you forgot why I'm able to do that. All right, we're moving along here. Let's get to the interesting stuff. Number 6 is digitally change through the rainbows of the color as you turn the potentiometer. Okay, so I'll do this kind of like the proper way. What we're saying is that we want to go through Roy G. Biv. So that's 7 colors, I believe. 7 colors, okay? And basically, as we turn the dial, it should just turn right away. Like red turns right away to orange, turns right, and then as you turn red, turns right away to yellow. It doesn't fade. So that shouldn't be too bad. Let's go ahead and do that, okay? So first thing I want to do is, just want to make sure, Roy G. Biv, yeah, 7 colors, okay? So I want to split up my whole thing here into 7 different even segments, okay? So the first thing I want to do is divide. My potentiometer goes from 0 to 123, which means it's 0 to 1023. So then it's 1024 different segments, and I want to divide that into 7 equal parts. So let's go ahead and go to my calculator here. So 1024 divided by 7, boom, is 146. Okay, that means if I want to split my 1024 potentiometer into 7 equal parts, each segment is going to be 146 about. So I just do this. 146. Okay, and then now it's like getting a little bit crazy here. Is it 292? Is that right? 146 times 2 is 292. Okay. And then, and you know what? I think this is kind of just like a quick and easy way to do this. You could also do like this, okay? So 146, and then you can say inside here, actually put a math expression. 146 times 2, okay? I think you could do that. Let's see. I may be wrong. 146 times 3. 146 times 4. Okay, so usually you would just, do the math and then put it in here, but so it's just kind of a trick that I want to show you. 146 times 5. 146 times 6. Okay, and one thing to note here, when you write the expression, you need to make sure that it's encapsulated by the 2 parentheses. Okay, just like in doing math, order of operations. Okay, you need to tell the computer that I'm trying to do these 2 numbers multiplied, so you need to surround it by parentheses. All right, so I've so far 1, 2, 3, 4, 5, 6. I need one more. Times 7. Okay. And what is 146 times 7? Let's see. 146 times 7 is 1022. Okay, that works out, right? So my last one is basically if it's greater than this number, then we're going to get there. Then I want to do the last intensity, or the last color. All right. So now that I have those set up, I can then add in my colors. Now before I do that, I'm also going to add this. 146 times 1, just so that it's clear, right? I mean, 146 times 1 is 146, but just so my code looks more clear, okay? Because I have 1 through 7, so it's clear I have 7 different segments here. Is this right, guys? I think so. Okay. So I'm gonna say when it's 0, I'm just gonna turn everything off. All right, so then I'm gonna go and find my RGB stuff. RGB off. Okay, hopefully you still have these in your code. Boom. All right, then when I get to this level, I want to do red, which is going to be not that one, which is here. Okay. Then I come here. Oh, sorry. That's not what I want. I want not the whole function, just the function name. Okay. RGB red. Function call means I need 2 parentheses and my semicolon. Okay. And I think I know I can just guess the names. Like if I was good at it, I would have called the for orange RGB orange in camel case. Okay. And so that's why it's smart to kind of keep a convention for your function names. So you can just be like, okay, well then for yellow it should be RGB yellow. And I'm just curious, just want to make sure. RGB, yep, see? All right, so keep things organized. It's going to make your life easy, okay? Another lesson there. Okay, red, orange, yellow. Then I have green. Then I have blue. Is that right? Yeah, okay. Then I have indigo. Again, these are all functions I wrote before. And then I have violet. Okay, so hopefully this works. Let's try. Okay, so I'm gonna upload this, and I have a issue here. So it looks like, oh, I think I'm missing, let's see, 140. Okay, let's look at this error. It says line 181. Okay, it says 181 there, so let's look at 181. Oh, okay, I'm missing a parenthesis. See, so these two parentheses go together to tell me I want to multiply 146 times 1, but see this parenthesis for the if clause, it's missing a parenthesis, so I need another one here, boom, to match this one. Okay, and as a quick note, if you look closely, there are this little box that goes around the parenthesis. There's another box over here that tells you this one matches with that one. Okay, now let's try again. Oh, okay, uploaded. Let's see what happens here. Okay, cool, man. Let's, sweet. Okay, so I'm off, red, green, blue, indigo, and violet. Sweet, I like it. All right, so that works. Now, just want to do it one more time just to make sure. Yeah, it ends on violet. Now I'm going to save this because I do not want to lose this piece of code here. Copy. I'm going to make void, what is this? RGB with, let's do our whole camel case thing. RGB with potentiometer, and then paste it all in there. Boom. Okay, so in case I want to bring this back later, right? Now let me save this. Okay, upload this. Wait a second. No, that's not gonna work, because this, good thing I did this. Okay, so because this one, this function here uses potentiometer, right? But look, inside of this function there is no potentiometer, so we need to pass the parameter through, and we've done this before. So we need to put this potentiometer into here so it can use it, and then over here we say int potentiometer. All right, so now we're passing in the parameter so that it can then use it to do the code. Okay, upload just to make sure it works. Should be fine. Starts, yeah, with red, and then should slowly go to blue, indigo, and then violet. Cool. Looks like my, there we go. Okay. Now let's save this. Okay. RGB with potentiometer. Okay. All right, so at this point, what we want to do is do that last challenge, which is going to be the fading as you turn, fading through the rainbow as you turn the potentiometer. So let's give this a shot. I've been thinking about the best way to do this, and I'm actually not sure if, excuse me, if it's gonna work, but let's try it out. All right. So what I'm gonna do is gonna look at the RGB fade. I already have a function, right? Going down here, rainbow fade, okay? That does my fading. So I'm gonna copy this, okay? And I'm gonna put it down here. All right, and let's just make sure this works. I'm gonna take my rainbow fade function. But before I do that, I'm going to call it rainbow fade potentiometer. Okay. And but right now it doesn't do anything except for just the fade, right? So let's do that. Okay, so it just should fade from the red and then to the orange and so forth. And it looks like it is doing that. So we'll let it go as we talk. All right, so as that's going, let's talk about how we're going to modify this. So the first thing that we want to do is we want to bring in the potentiometer parameter. So we're going to put potentiometer into there. And let's also put it into here, into potentiometer. Okay. And once we do that, how are we going to integrate this thing? How are we going to bring in the potentiometer? So what we want to do is actually, we want our code to the first thing we do is we want it to start at, when we're at 0, potentiometer is at 0, we want it to do nothing, I think, right? So we're going to do something called the while loop. I'm trying to think if we've covered it before. I think we have, yeah. So while potentiometer equals 0, do nothing. Okay, so what we're saying is while the potentiometer is 0, just chill here. I don't want you to do anything. Don't turn on any lights. Don't do anything. Okay. And then once it becomes bigger than that, or anything other than 0, it will then jump to do this. Okay. Then we want it, after it does the red, we also want it to chill out and do nothing while potentiometer is less than 146.2, or 146 times 2, I mean. Okay? So from 1 to 146, it will do this one time and then just wait here. Is that right? Is that right? I think it's right, but here's the idea is right, but here's the problem. Okay, we're gonna be getting a potentiometer comes through here, right? Then we test for potentiometer. So let's say it's 0, then it'll go at 0 and it'll get stuck here, but then what happens is like potentiometer will always be 0 if you're here. Because as you change the knob, there's nothing in this code, in this function, that actually looks at the analog 0 knob input. See this? Potentiometer equals analog read 0. So what that means is that we need to actually take this code and put it inside here. Okay, and I'm going to then get rid of this because we already have our own potentiometer variable in here. And before each time that we do this, we need to read the analog 0. Okay, so what's going on here? We're staying at 0, but while we're in 0, we need to actually update to the potentiometer variable value. We need to keep reading the analog A0, which is connected to the potentiometer. Okay, if you stop reading the analog A0, then you're basically like, you're just gonna be stuck there, right? So you got to keep listening, keep sensing, okay, so that you can sense any movement. So now we have that going. We can then take this same code here I'm gonna make it like this. I'm gonna do this. Okay. And say here. All right. So the key thing here is as we're waiting and doing nothing, we're actually still reading potentiometer to see any changes on the potentiometer by reading A0, analog read. All right, I think I almost got caught there. That would have been kind of hard to figure out. Okay, so after we do orange, then we're gonna do one B in potentiometer while it's less than times 2, and then we just keep going. Okay. Again, I've never tried this, so hopefully we get a good result. Times 3. Times 4. Times 5. Times 6. And then after that, do I want to turn it all off? Sure, why not? So then like after, or maybe I don't. Maybe I just, I don't know. I'll take out this delay and stuff for now. Okay, I feel like, okay, and then here, I'm gonna get rid of this because we no longer need to pass through the potentiometer for rainbow fade potentiometer, because again, we have our own up here inside our rainbow fade potentiometer function. Okay, let's try it out. Hopefully we get something good result here. Okay. Let's see here. I think we're at, did I turn it all the way here? Let's go to the monitor, just see what we're at right now. Okay, we're at 0. Okay. I think I didn't know where it was before, so that's why. Okay, now let's turn it slightly. Then I should have the red fade on, and then just chill out. Like, no other colors, please. Okay. And then I'm going to turn it a little bit more. And then, yeah, I'm getting orange coming. And it should just, or maybe I'm going to jump to yellow maybe. Turn it a little bit more. I think it's green now. A little bit more. And try to get the blue to come out. A little bit more. Yeah, okay. We're fading to the blue. Cool, cool. And then it should go indigo a little bit more. Give me some indigo. Giving me some indigo, and then I keep going. And yeah, I'm getting me, it's fading to my violet. Yep, there we go. I don't know if you can tell, but definitely violet. Okay. All right, and then what happens when I go all the way back to the 0? So I think let me go back here. Once you go to the blue, oh, I see. Wait. Oh, there's something weird. Oh, I see. On the last one. So on the last one, we had it'll go to violet, right? But then I don't have it wait here for anything. Okay? It just, so what's going to happen is after it does this, it's going to jump out of the function and then do it again. So that's why you're going to see like a repeat of the last one. Okay. I'm just going to leave that there for now. You could try to fix that so that it doesn't jump back and redo the violet fading. But this should give you an idea. So we had a good little challenge here, and give you an idea of how to fade with the potentiometer. All right, so let's save this. Rainbow fade with RGB. Oh, potentiometer. Okay, so now that we have that set, let's go ahead and jump into what we're going to learn about today. All right, the new thing is we're going to be working with servo motors. All right, so I have our servo here. All right, I'm going to move this. It's a servo motor. Let's go ahead and pull it out here. I want you to notice that we have 3 different colors, this cable here: brown, red, and orange. All right, and then we have these propellers here. All right, the first thing I want you to do is you should have a popsicle stick. Let's take that out. Okay, and let's take out one of these sticky foams here. And let's put it on the end here, and then make it sticky. All right, here, and we're going to stick this onto one of these propellers here. Go with this one here. All right, let's go. Actually, no, I'm going to go with one that has more surface area to stick to. Let's go with this one. Okay, and we stick it on like so. Something like this. Okay. Having the bumpy side sticking up so that you get good surface area to the sticky foam there, and then this can then stick onto our motor here, like so. Should just snap in there. All right, there. So what we're doing, we're just extending this. It's called a servo horn or coupling. We're extending the servo horn with this popsicle stick so that we're able to see more of the motion. Okay. All right, so we got these 3 colors. Let's go ahead and connect these up. All right, so if we're gonna get the colors, we need pin-to-pin cables. Let's go ahead and grab that. And I think we should have, just double checking here. I have a black, orange. Do we have another red? Maybe I've used up both of my reds, so I'm going to use okay, I got a brown, I have an orange, and let's go with white. Okay, ideally we want to use red, but you know, we just use what we have. All right, so we'll go brown, and again these are pin to pin. Okay, brown to brown, like that. So red, we're gonna go to white. And orange to orange. Okay. Now, the way the servo motor works is that the brown and red are going to be the power and the common ground. So red is going to be connected to the 5-volt power. And so we're going to take this and then get to our Uno here. And we're going to find 5V. Now 5V is already used by the potentiometer, but we know how the breadboard works, right? This entire row, so we follow this red wire, this entire row here is 5V now, so I can just take my white wire and stick it into that row. It's a little tight. I'm going to turn it a little bit. There it goes. Okay. And then we're going to use the orange, actually not the orange yet. The brown is going to be the common ground, so I need to find a common ground at G and D. Where's G and D? Well, the potentiometer is also connected to this brown wire, okay, which is connected to this black wire, which is connected to G and D over here. So that means that this brown wire here, I'm tapping with my finger, is already G and D, so just put this one into the same row. Okay, good. Now what do we do with this one, the orange? Okay, the orange wire is going to be connected to the signal that controls the movement of the servo motor. So we need connected to a nerve. And so let's go with number 9. So we look at, oh, my potentiometer fell out. Let's put this back. Okay, number 9. So I find my, here, find number 9. Stick it in. There we go. I got my motor all connected. All right, let's go ahead and just jump into the coding here. All right, I'm gonna take this out for now, and let's do the servo motor. All right, so we got a servo motor. The first thing we want to do is put in servo.h library. All right. This is telling the code that we want to be able to move this servo motor here, and we need to access some functions that are in the servo library. So we put in this servo.h with these greater than and less than delimiters in there. Now we're going to set up our servo motor by saying servo, and then we're going to call this my servo. All right, that's a servo object. All right, now we've created the servo object and we called it my servo. You can call it something else if you want, but I'm calling mine my servo. Then inside here we want to do set up our pin. So pin mode number 9, because we connected it to number 9, and we want to make sure it's an output. Okay, servos, we're going to be outputting motion, so that's why it's an output. So we have our pin set up. We've created our servo object name, which is called my servo. Then here we're going to also do my servo, which is my servo object name, dot attach 9. Okay, so what we're doing is saying, okay, this is my servo here, my servo objects. I want to attach nerve or pin number 9 to it so that I can control it. Okay, now we just try to move it. All right, so we go down to my loop here. Okay, and I can say my servo dot write, and then I put something inside here. Now here's the thing about servos. It can only move between 0 and 180 degrees. So a full circle is 360. Servos do not move 360. They only move half a circle from 0 to 180. Okay? So you just put in an angle, 0 to 180. So I'm going to say 0. And let's see what happens. Now, one thing to note is that whenever your servo motor turns on, it goes to around 90 degrees. Okay? So let's see. So if I put this here, it should move. You should see it move to 0. Let's see. All right, I'm gonna plug in. Okay, here's my, see my popsicle stick there. All right, so let's go ahead and upload. And I totally messed up. What's going on here? Servo line 23, I have issues. Line 16, it says unqualified ID. Okay, let's see what's going on here. Line 16. Oh, you know, sometimes I go crazy. I messed this up. It should be hashtag include. Okay, the servo library. Sometimes you forget, but you have those error messages that come up that can tell you, okay, check out that line, you forgot something. Okay, has to include servo. All right, then we upload, connect, and you see that? It moved. All right, so right now we're at 0, and let me turn it this way. Okay, so I'm holding this. All right, it's at 0. Let's go down to my code. Let's now turn it to 90. Okay. Yep, you see it move. And then let's turn it to 180. And it goes to 180. And it could go to any number in between there. So let's say 160. You could also do. See, it moved up a little bit. And you could do like, let's make a few movements, right? So let's say if I wanted to go 0 to 90 to 180, how would I, would that work? Let's see what happens here. Okay, so not quite working. It's not going 0, 90 to 180. Okay, the problem is that we need to add a delay to slow down. So it's saying 0, 90, 180, 0, 90, 80, 180, like really fast, not giving it time to actually get there. So we need to put a delay. I'm gonna say 1 second. Okay. This should work. See that? Now I have the movement 0, 90, 180. Okay? All right, so that's just a quick example of how to get this thing to work. So I'm gonna stop this now. And let's give some challenges. All right, so quick and easy. I just wanted to give a quick how to get it to work. All right, so now I'm gonna go and do some challenges. So this today, what we want to do is recap of what we did. We make sure servo motor works by testing 0, 90, 180. So we did that together. Okay, different angles. Then get servo motor to cycle between 0, 90, 180. All right. And now since we learned a little bit about resolution, remember with the RGB changing lights, let's do get servo motor to cycle between 0 to 180 with resolution 6. So this up here, number 2 is resolution 3. So resolution 6 would mean 6 different segments between 0 and 180. Okay, but I want it to cycle through, so don't forget your delays. Then cycle through resolution 10. Okay, and then control number 4, okay? So the same resolution 10 between 0 and 180, but control number 4 with potentiometer. So what that means is, as I turn the potentiometer, I want the servo motor to move with a resolution of 10. So 10 different movements as you turn the potentiometer. Okay? So that's something, it's similar to kind of the RGB thing, but we're using the servo motor now. All right. And then, you know, as a bonus, why not? Let's get the RGB. So we get number 5. Okay, so that means, so we're going to add on to the number 5 code. So as you're turning, I want the potentiometer to be cycling between, as you're turning the potentiometer, I want the motor to be going through 0 to 180 with a resolution of 10, but also with RGB rainbow colors. Actually, now that I'm thinking, no. To make it better, let's say get servo motor to cycle between 0 to 180 with a resolution of 7, because there are 7 colors in the rainbow. As you change angles, cycle through rainbow colors. Okay, so you're turning the dial. As you're turning the dial, the motor's moving. As the motor is moving, it's also going through the different colors of the rainbow. Okay, and I'm just gonna say, just don't worry about the fading thing. If you want to do the fading, you can also add the fading between the colors as you change the angles, but you know, that's a bonus. I need to think on that one too, how I would do that. All right, but 1 through 6, give it a shot. If you have questions, of course, reach out. I will talk to you next time.